All right, let's review section 8.2 before we look at putting it all together in a four-step process. So section 8.2, we were trying to estimate the proportion, percents. The symbol for the statistic for proportions is p hat. The symbol for the parameter is p. The name of the procedure is a one sample z interval for proportions. So I'm going to put for p. The random condition needs to have a simple random sample somewhere in the problem for the random condition to be met. Remember, the 10% condition is testing for independence. So your sample size has to be less than or equal to 1/10 of the entire population. And if you are told at the beginning that the independence condition has been met, you don't have to check independence. But remember, we do this when we are sampling without replacement. And then the normal condition for proportions is large counts. So that was n times p hat and n times 1 minus p hat is greater than or equal to 10. Or you could look at it, n times p hat is the number of successes, and n times 1 minus p hat is the number of failures. And both of those have to be greater than 10, because sometimes they give you the successes and failures and you don't have to do any calculations. The formula for the standard deviation for proportions is also called the standard error, is going to be the square root of p hat, 1 minus p hat, divided by n. Will we use z star or t star for proportions? We're going to use z star. The formula for your margin of error, remember your margin of error is your critical value times your standard error. So in proportions, it's z star times the square root of p hat, 1 minus p hat, divided by n. The general formula for the confidence interval is your point estimate, otherwise known as your parameter, plus or minus the margin of error. And the specific formula, so our point estimate for proportions is p hat plus or minus, and then of course your margin of error we've already done, your critical value times the standard error or the standard deviation, p hat 1 minus p hat divided by n, all under the square root. So that is an overview of what you learned in section 8.2.